Hello everyone, today I'll be covering applications of derivatives in motion. The three main motion quantities are position, velocity, and acceleration. Position is a measure of where an object is. Velocity is a measure of how fast that position is changing with respect to a change in time. And acceleration is how fast the velocity is changing with respect to a change in time. Position is represented by s of t or x of t. Velocity is often represented by v of t or x prime of t, as it's the first derivative of position, and acceleration, being the first derivative of velocity and the second derivative of position, is represented by a of t, v prime of t, or x double prime of t. A common example type is finding the instantaneous velocity at some time. First, given this position function, we first want to differentiate it to get our velocity function, making sure to use chain rule. Then we substitute in t equals 1 into our velocity function to get our velocity of 3 over 2. Another common problem type is finding when acceleration is negative. First, given this position function, we actually want to differentiate twice this time because acceleration is the second derivative of position. Then we solve the inequality for when our acceleration is less than 0, and we get t is less than 3. A more complicated problem type, however, is finding the intervals when an object is slowing down. Given this position function, we want to differentiate twice, making sure not to forget either function because we need both. Then I like to draw a number line with the critical points, or when velocity or acceleration is equal to 0. Then I want to plug in within these intervals, I want to plug in a value to both the velocity and acceleration functions to see whether or not they're greater or less than 0. Now, for the interval 0 to 1, we can find that velocity is positive and acceleration is negative. And since the signs are opposite, we know it's slowing down. For 1 to 2, they're the same sign, meaning speeding up. For 2 to 3, they're opposite signs, meaning they're slowing down again. And then from t equals greater than 3, then we know that they're speeding up because velocity and acceleration are the same sign. Because of this, we know that the object is slowing down from 0 to 1 and 2 to 3. Thanks for watching, and I'll be covering applications of derivatives not related to motion in my next video.